My name is Alberto Diaz, Operations Manager at Visual Aim, and this is a quick presentation and introduction to our inspection data management system, which we call the Mechanical Integrity Suite. What you're seeing on the screen is the main inventory of all assets that exist on the database. You can simply click on any one of those assets to get to the information that pertains to the particular piece of equipment. I'll use tank 1201 for today's explanation. When you click on the asset, it lands on the main properties table of the piece of equipment. You will see that the information is subdivided into logical groupings of data, which can all be opened by clicking on this expandable icon at the top right. In the identity field, one of the key things to point out is the fact that we do have a reference to the CMMS data. This can be for SAP or any other computerized maintenance management system, where our customers like to link both systems together to automate the creation of work orders in the work order system based off of recommendations that are input through our previous inspection record keeping system. And we'll talk about that a little bit more later. Some of the key properties here are also pertaining to design and construction. Once you apply a construction code, this will bring both the calculations for the minimum thickness of the particular asset type based on the code, as well as the allowable stresses of the materials that the code allows. In terms of the operation, this key date, which is the date in service, as opposed to the construction date, will be the one that kind of sets the time clock on inspection schedules moving forward. We do have a section for additional properties, which are highlighted as you can see in blue. These are additional metadata fields that the users can add if we don't already have them as preset properties in our main set of data collection fields. And last but not least, we've got the actual component properties. You will see that for our fixed equipment, both pressure vessels, heat exchangers, as well as storage tanks, you can componentize the assets to the level of specificity required by your operation. In this tank example, you can see that the asset is divided into 5 shell courses and a roof with all of the pertinent material properties of each, including materials of construction, joint efficiency, diameters, lengths, nominal thicknesses, so on and so forth for each and every one of the components. If the user wants to add or edit any properties, they can simply scroll all the way down to the edit option, and this will pop up the view for the additional data categories for the particular component. This will reiterate what I've shown before, but from the panel of where you can add the additional options. Here, I just want to point out 2 quick things. First and foremost is that we have a whole slew of process parameter information. This is data that's not necessarily required for a time-based inspection program, but it is for an RBI program, which we do have the capability of also accommodating. That's why you will see a number of additional data fields that might seem like an overkill from a time-based perspective, but not as much from a risk-based perspective. And it is for that reason that we also have the flagging information for all of the susceptibility criteria of the 21 damage mechanisms in API 581. To navigate to the other modules of the software, I will be using this compass icon to jump from one section to the next. What I've shown is the main panel of asset properties, and when you click on a module, it'll show if there are any additional subcategories of that module for the asset. In the case for properties, we also have a section for files. This section portrays all of the files that are associated to the particular asset. For this piece of equipment, you will see that we do have a general construction drawing, as well as a record of inspection that's got an inspection PDF associated to it. I can click on it to visualize this inspection, to pop up the particular inspection document, and you will see that this is linked to what we call a previous inspection category. This is because that file was uploaded into the piece of equipment through an inspection record, which I will show next. The general file is a general file, in this case a construction drawing, that was directly uploaded into the file section of the software. Next up, I'll go into our inspection plan module, and specifically the previous inspections subset of the module. When I click on it, you can think of this as a filing cabinet with all of the inspection records of the asset. This piece of equipment is going to have 4 records, with the latest one being in 2019. Upon clicking the record, you will see the different properties of this particular inspection, including general properties that includes the type of inspection, when it was executed, the inspector, the company, the brief summary. You can specify with a great level of detail the actual methods that occur depending on each and every one of the components, with their minimum thicknesses if they apply to the inspection method, as well as the inspection document associated to that inspection record. You will see that this is the same document that I pulled up previously. I'm just making the reference to state that this document was uploaded through previous inspection, but it's still viewable through the panel of the files for the overall asset. If the inspection included any thickness readings for the inspection, we do have a module that we call NDE, non-destructive examination, where all of the thickness readings can essentially fall under. In the first subset of the module for CML properties, here are where the CML and TML points are preset in order for this to be uploaded into the platform. You will see that each CML would have a descriptor, and under it I can have all of the different TMLs that are associated to this particular CML. This one that we're visualizing is for shell course number 1, and you can see all of the different orientations that this particular CML has. The properties of the CML are associated to a component, but they can also be edited accordingly if you want to have specific information that pertains to this particular inspection CML. Once the CML points are set and configured, you can then start uploading the thickness readings through what we call the shooter sheet. The shooter sheet would basically be a panel where you can enter the new thickness readings for a new inspection date, and you'll have a reference to the prior thickness reading as a visual guide or reference. To input the readings in, you can type them in yourself, or you can download the shooter sheet template. What this will do is download for me an Excel spreadsheet where I can basically put in all of the different thickness readings for my inspection. For demonstration purposes, I'm simply going to make these all 1/4 of an inch. I'm going to save this file, and I'm going to go ahead and upload it into the system. Once I come into section of the software, I'll upload my set of readings, and you'll see that these are all now 1/4 of an inch. I do have a neat little tool to understand if there's growth or loss in what I'm putting in here. You can see that all of these readings are below the prior, so they're all being marked in blue as being loss as compared to the prior reading. But if I had a higher reading, such as, let's say, 0.4 or 0.5, it would flag it as a growth because the reading that's being imported is slightly higher than the prior reading. This is just a visual reference to double check the data that's being put in. Once I save this record, it'll become part of the historical readings. The historical readings are going to portray all of the thickness readings that have been taken for the asset across time. If you recall from the previous inspections panel, this asset had 4 distinct inspection records, which are being shown from their thickness reading perspective. I can open up to see the particular TML readings, and by clicking on this action item for the graph, I can visualize how the thickness is trending across time. This is obviously an asset that's not in a very corrosive surface, and you can see the amount of material that there is left to be corroded before reaching this red dashed line, which represents the minimum thickness for this particular component. After visualizing this, we can jump over to the calculations for this asset, and this will run all of the long-term, short-term, and remaining life calculations for the piece of equipment based on the thickness readings. Once the calculations are executed successfully, I can come into the calculation section, scroll to the right on the short and long-term corrosion rates. Of the two, it's going to pick the highest one to estimate a conservative remaining life. And if I rank order these remaining lives, you can see that 2.94 is my lowest, which is in nozzle number 9 for this piece of equipment. All of this information and any table inside of the database can always be exported into Excel. In the case that you want to do any additional analysis or reporting, do note that that option is always available across the software. Once this step is complete, the only final action to take is to create a new inspection plan. This inspection plan is essentially gonna dictate when your next inspection date should be, which in this case, if I scroll down to the methods of this asset, you'll see that it's scheduled for another external visual inspection and another UT thickness 5 years from the prior. So it would actually be coming due in April of our current year. So based on this information, all of the reporting that you would then see from the software would be based on the data that comes from these inspection plans from a scheduling standpoint. And in terms of these schedules, we have a number of dashboard views that can be visualized for the information. This is an example of a customer that manages 14 different facilities using the Mechanical Integrity Suite. And you can see from the dashboarding perspective that it itemizes all of the assets that are past due for inspection and into the future, subdivided by facilities. So if you have multiple facilities in the same database, you can have these analytics for the visualization of the inspection schedules into the future. Above and beyond the Mechanical Integrity Suite, we have an intelligent drawing platform tool that we typically package up with the Mechanical Integrity software for purposes of data extraction and data connectivity. When we refer to the data extraction piece, once we process the files, we're able to essentially categorize all of the equipment components that exist on the drawings, giving us the ability to, for example, narrow down and understand how many individual instruments exist on the set of drawings, how many motors, how many flanges, how many direction arrows. This then gives us the ability to essentially export what we call takeoffs of the equipment. So if I portray the example of a takeoff, this is an example for a client that we did a relief valve inventory based on their drawing set. We're basically able to extract the information off of the PNIDs. This is typically very valuable when setting up the Mechanical Integrity database because we can use the drawing as the basis for the master equipment list that is going to populate the software. Beyond that, we can also do interesting things in terms of visualization and data connectivity. In terms of visualization, one key thing for Mechanical Integrity is being able to reflect the piping circuits that exist on the PNID drawings. These piping circuits can then be associated with their isometrics. As an example from this view, I can click on the label for the piping circuit reference that's shown on this PNID diagram. It'll bring up a set of navigation links, one of which will be to the isometric drawing of that particular circuit, where CML points in this situation are actually connected with the Mechanical Integrity software data. So I can visualize information such as the remaining life of each of the points in a color-coded scenario, the corrosion speed of each of those points, and if I want further information of the point itself, when I click on it, it's going to pull data from the Mechanical Integrity software to show me properties of the CML, calculations in terms of corrosion rates and remaining life, in a similar graph to what I showed inside of the Mechanical Integrity Suite, but visualized over the drawings. Again, this is data connectivity to the Mechanical Integrity Suite that's being pulled at the moment when I click on the CML. This is not information that's being replicated or stored in parallel also in the intelligent drawings. If you do decide to adopt both solutions, then we have a third sort of tool that would allow to integrate both of these data sources along with 3D modeling software. And this is an example that we have that we like to showcase where all of the products kind of come together. If I use the example here on the screen to search for an asset, let's say that you're looking for filter F1500. This will tell you first from a locational perspective on a map where it's located on the facility. It'll bring in view from a 3D perspective the asset location where the asset exists. This can be a photogrammetric model, which is what you're seeing on the screen, or it could be a geometric model if the 3D technology that is being used is compatible through application programming interfaces with our products. You will see that it also brings the intelligent drawing that contains that reference. So let's say if you're doing a lockout tagout, for an example, you can visualize the 3D model next to the 2D visualization of the asset so that you can clearly see what are going to be all of your lock points for the piece of equipment. And then finally, it'll also pull information from the Mechanical Integrity Suite software. That's going to include basic properties of the asset as well as scheduling for your last and next inspection dates due for the particular asset. So this final holistic view is just to show what is possible. The main intent of this presentation was to showcase the Mechanical Integrity Suite, but I wanted to wrap it up with this information so that you can see what is possible once you have all of the products put together. Thank you very much for your attention.